All right, welcome to section 4.5. Section 4.5, where we're going to start talking about how do we name compounds. We learned how to form them a little bit, but how do we name them? And what we have to do is we do have to finish up a couple odds and ends from when we form compounds. And here are a couple odds and ends. There are a handful of metals that have two charges or multiple charges. And they will only give you one of the two charges, but just to kind of keep you informed. Like, for example, lead can be +2 or +4. Tin can be +2 or tin can be +4. Let's see what else. Iron can be +2 or iron can be +3. Now, we're not going to get into the details of why they have multiple charges, but I just want to let you know that there are a handful of elements that have a couple different charges. So it's possible you may see both lead with +2 or +4, and that's just a handful of elements, and they are metals, have the capability of having more than one charge. And they're typically transition metals. So and when a metal forms with more than one ion, we're going to name it differently, and we're going to name it with Roman numerals in parentheses, and we're going to explain that process today. So kind of tying both together. Metals with multiple ions exist, and if they have a multiple ion, you have to name them slightly differently than you do if they wouldn't. So also, we have this thing called polyatomic ions. What does the word poly mean? Poly means what? Anyone know? Poly means many. So let's say this again. We have many atoms forming an ion. What's an ion? It's a charged particle. So a polyatomic ion is many atoms combining together to form an ion. For example, CO3 has a charge of -2. See how we have many atoms put together? We have 1 carbon and 3 oxygens, and it still has a charge. How about this one? PO4 has a charge of -3. 1 phosphorus, 4 oxygens, multiple or many atoms, and they have a charge. So polyatomic ions are many atoms with a charge. So it's possible that you may see those here and there. You're going to get a sheet which kind of tells you what each one does. And it's possible that they are positive or negative. So like I just said, the prefix poly means many. So just kind of keep that in mind. And most of them are negatively charged. That's all I want you to know. What I wrote in green is the big part for polyatomic ions. Now, to the meat and potatoes of this. How do we name compounds? All right, how do we go ahead and name them? You'll want to write this down step by step. We have to use a step-by-step process to name an ionic compound. And it's different from any other ionic compound. So, you see the formula as stated in section 6.2. It describes the ratio. You see NaCl. You already may know that the name of NaCl is sodium chloride. But how do you know that? Well, there are rules that chemists follow. And we are going to learn how to name binary ionic compounds. How many are we going to name if we have binary? 2. So we're just going to name 2 ions together to name a binary compound. So what are the rules? Well, I just said that. A binary compound is made from 2 elements. Here are the rules. The name for the cation is unchanged. So you just simply name the positive. If it's sodium, it's sodium. If it's lithium, it's lithium. If it's calcium, it's calcium. If it's iron, it's iron. Nothing changes with the positive. The change that happens is with the, what the heck? Sorry, I goofed up my PowerPoint here. Nothing happens with the positive. The negative, you have to change the ending to "ide." The negative is always ending in "ide." So if we go through negatives, chlorine becomes chloride. Bromine becomes bromide. Oxygen becomes oxide. See how that works? And when you write the name of these, the positive always comes first. Negative second. Positive first, negative second. So let's use these rules. Let's go through and explain how they're going to work. So I have, let's say I have Sr, which is plus 2, and Cl, which is minus 1. If I combine those together, I'm going to get SrCl2. Well, how do I name that? Well, what is my positive? My positive is strontium. Remember, the positive never changes. Strontium is always strontium. My negative, though, changes. Remember, you're always changing your negative ending to "ide." So chlorine becomes chloride. All right, let's go ahead and let's do another example. Do another example here. Mg plus 2, O minus 2. Crisscross my numbers. I get 2 and 2. Uh-oh. What happens when I get the same numbers? I cancel them out just like a fraction, and I would get MgO. Now, let's go ahead and let's name MgO. What's the positive part of MgO? Mg. Remember, you're always naming the positive the way it is. So Mg is magnesium. I'm just going to write magnesium. Next, the negative, which in this case is oxygen, always changes to "ide." The negative changes to "ide." So oxygen would become oxide. How about that, huh? Pretty neat deal, isn't it? Magnesium oxide. All right, let's do one more. Let's see if we can get one more here. Want to do a difficult one? Bring it up a notch? Let's bring it up a notch here. Let's go. Oh, what do we want to do? Let's go. Ooh, that's a good one. Let's go Ba plus 2 N minus 3. Well, I'm going to prefer the crisscrossing method. And I'm going to get Ba3 N2. Now let's go ahead and name that. What's our positive? Our positive is Ba. What element is Ba? It's barium. Remember, you never change the positive. It stays the same. So Ba is barium. Then I always change my negative, the ending nitrogen, to "ide." I always change the ending to "ide." So nitrogen is going to become nitride. All right, so barium nitride is Ba3N2. So those are the simple tasks that you have to use when naming ionic. Remember, when you name ionic in review, the positive never changes. You always name the positive as is, and the negative always goes to "ide." So keep that in mind. This is Mr. Kleinert, and I'm signing off.